Thanks, Mark. Chief Davies, fellow chiefs, flag and general officers, ladies and gentlemen. It's my high honor to be invited to address the Air Power Conference. I have been back to Canberra twice before this to talk to Williams, and so it's a great honor to be back. I'm humbled to be able to take the podium and present to you under the benevolent gaze of my newfound uncle and auntie and the original peoples, and they obviously have a sense of humor because they have me following Genevieve Bell. And so I hope to give you a little bit of a kind of a discussion point today on a set of pedantic rules that we need to look forward to as we go forward in this digital age. A fifth-generation warfight requires partnership between industry and defense. And when I said defense today, I mean roughly those people in the government defense agencies, uniformed and civilian, and industry being people that look like me. We need a partnership going forward. So the thesis today is that partnership has to get stronger. We have to fix our processes in order for us to be able to succeed in this fifth-generation fight. I did transition from the United States Navy, but I'm not a pensioner. The quickest way to get to be a pensioner is to represent to you today that my presentation is official Boeing policy. It's not. These are my views as a 3-decade Tomcat fighter pilot. By the way, Genevieve talks about carbon-based, silicon-based. I'm carbon-based, probably closer to early man. Don't have any hair on my knuckles because they drag. So I give you fighter pilot perspective about going forward. But these are my personal views based on my experience. And by the way, Kitch, that's not me. And if you want to figure out who that is and what they did after that, then come over to the speaker's corner at morning tea and we can talk about fighter aviation. This thing is exceeding my carbon-based stuff. So Einstein said that if I have an hour to save the world, 59 minutes will be to define the problem. The problem is our current process takes too much, takes too long, and costs too much. But we continue to go back in there and expect a different result. I'm on quixotic ventures all the time, tilting at windmills all the time, trying to fix this process. We've got to fix this process collectively. There's wide bipartisan agreement in the United States that our current process doesn't allow the United States military to respond quickly, or that defense industry could respond in the way we did in World War II. We must change the model. We can't just operate around the edges. We have to come up with a new process that we can collectively go forward in to take advantage of the innovation that's out there for the fifth-generation fight. As we look at the environment that we're all going to operate in, there are 4 forces that drive change to go forward. That environment affects everybody. It affects competitors, it affects allies, it affects competimates. The first one is the maritime system. If you stand any place in Australia and look in any direction of the compass, you will get to a maritime boundary. Same with the United States. Logistics pipelines, destinations, sources. More than 95% of the world's merchandise moves across the sea. In the decade 1992 to 2012, maritime commerce increased 300%. In the Indian Ocean, the centuries-old center of trade, fourfold, 400%. And while ships are about the same speed as they were in the late 1800s, about 18 knots or so, look at all of the material that moves in the biggest ships we have. 25% of the world's oil and 1/3 of the natural gas goes through the Indo-Pacific maritime region. The maritime system, global maritime traffic, is critical to our survival. Talk about maritime commerce, the freedom of trade, open seas, points for conflict. The information system, currently 2.5 billion people are operating an information system. They each have about 2 mobile devices. Between now and 2025, 1.8 billion people will join that consuming industry with 3 mobile devices. We double the amount of information in the world every 2 days. Undersea cables carry 99% of the world's voice and data, 95% of the United States voice and data. Interestingly, if you tried to move that to the high terrain into space, we think about beyond line of sight communications all the time. If you tried to move that almost 100% of translation of information up into space, you can only carry 7%. Undersea cables are critical. People using it, The technology they use is our third force, the rate of technology change. There's a great book by Friedman called Thanks for Being Late. And it talks about the rate of change to the human. It's going too fast. I can't keep up. How do I think about this? So depicted on the right-hand side, upper part of that chart, is 3 different ways to look at that. The number of patents for technology have increased exponentially. U.S. private manufacturing has increased in output exponentially as well, while jobs have remained roughly flat. Robots into the manufacturing space. In 2011 alone, robots in manufacturing space increased by 170%. Man-machine teams. You should think about that, talk about that. Genevieve talks about autonomous and AI. The assist with the human, where's the human in that team, is a more provocative way to move forward into the future. And then the internet, 62,000 or so hosts on the internet in 1995, now almost 1 billion. So if we were to take those first 3 forces and think of them as 3 currents in a river that we're paddling down in our kayak, then the 4th force at Navy budget is your paddle. I would contend that that paddle right now is a stick. You can't paddle very much at all. RAND and the Congressional Budget Office have projected that Western or allied defense budgets between now and 2025 are going to flatten or go down in real value by about 7%. So our resources to go after this rate of technology change in the environments of the global maritime system and an increasingly faster information system are increasingly harder to get. So I just draw a graph of the budget authority in the U.S. It already looks a little bit unpredictable. You throw an administration change on top of it, sequestration, Budget Act of 2011 for us, and then a continuing resolution. You heard a speaker yesterday talk about the fact that we don't have a budget in the United States yet. And so we don't have a stable or historic budget consistency to plan on. Deputy Secretary of Defense Shanahan spelled it out in the West Conference about how industry can work closer with defense. He talked about industry setting the standards. Government should agree to that standard. There's a deeper discussion on standards that if you take a long time to try to define a single standard, you're probably losing the innovation in standards to go forward. The American telecoms companies, as they progressed from the 1980s up to now looking at 5G, actually have a standards committee that gets together and talks about standards, but they never set themselves on a standard. Industry can set those standards. We can collectively get together. Industry is going to invest. DoD ought to guide that investment, talk about that investment, be very clear on how we integrate those, and then get together in a room to evolve those capabilities that both industry and government come up with instead of holding them close and then saying, here, try this. Data, information, knowledge, get it in the environment. And as we talked about with that silly Einstein cartoon, it costs too much and it takes too long. So at the core of the American National Defense Strategy is the ability to succeed in this space. On July 21st of 2017, President Trump issued an executive order calling for an assessment and a strengthening of the military, defense, industrial base and assessing the supply chain resiliency of the United States. In order for the United States to react to a crisis, maintain readiness requires the capability, capacity, and resilience of our industrial base and supply chain. The Aerospace Industries Association, based in the United States, responded to that executive order. They created a working group. 4 pillars to success. We talked about funding already and the fact that it needs to be balanced and stable and predictable. In an acquisition policy that can take those resources and turn them into capability in a rapid manner, capitalizing on the leading edge of technology. A talented workforce with specialized skill sets, entrepreneurial mindsets, with no fear of failure, inquisitive minds who say, what if we put chocolate with peanut butter? And then the stewardship of key capabilities. What you have here in the Commonwealth that is special. What we have in the United States that is special. What does each country have that is their secret sauce? What does each industry company have listed here that's our secret sauce? Steward those capabilities. maintain the IP, but bring the ability to put it together. So we maintain that competitive edge between countries and business, yet we still share the information. So a wordy slide here. I built it this way with the 10 fundamental priorities for you because you have access to these slides. You can take these away. So as you look at these 10 priorities, we need to buy back our readiness capability with balanced funding, but any budget or programmer has to balance current readiness, 0 to 5 years, the modernization of what we currently have to the future, so say 3 to 5 to 10 years, and then what does that future look like in 2028? That competition. If we only have enough money to put money into either one or two of those buckets, you diminish the other one. You have to have balanced funding to go to all three. How do we move to the future? We also have to quit jumping to the next bright, shiny object. When I was in the Pentagon doing the N9 job as the Deputy CNO for Warfighting Systems, we just loved to have the next bright, shiny object. I went to get the next airplane, the thing that I can grab onto. John Blackburn yesterday talked about a simple labeling of generations. And we did that with aircraft. So when I was flying a Tomcat back in the 80s, I learned how to fight a third-generation airplane or a fourth-generation airplane. An F-5 was a third-generation airplane, and F-16 was a fourth-generation airplane. It was a simple label and characteristic of that platform. As we move into a fifth-generation fight, it's a combination of various platforms and capabilities. It's a fifth-generation fight with F-18s, F-35s, Growlers, P-8s. And if you tried to label them in particular as fourth or fifth, you're not doing service to the fight that you have. And so as we look at that long-term planning stability, we got to reform the contracting process. I will tell you that it takes too long. Lowest price, technically acceptable, curtail that. Here, lowest price. Yeah, it works about right. Best value, we need to do that. Best value. And then you synchronize defense and commercial aerospace trade policies. So what is the commercial space producing that we can use in the military and vice versa? We talk about COTS or commercial. That's changed now, I think. Commercial technology is taking off, and we in the military have to grab a hold of the leading edge of that technology. Our people need to be more invested and inquisitive in STEM with specific skills, not only aerospace and mechanical engineering, plus cognitive computing in electromagnetic warfare, across the electromagnetic spectrum, creating machines that can look at a signal and say, that's not in my library, but I can put that together and figure out how to react to that. Genevieve talked about AI and all of that, machine learning materials, and then, of course, the data science that goes with that. We are a dearth of data scientists. When we look at our networks, you got to figure out the data requirements. Data rate, latency. Do I need to just do a weapons data set across a Link 16 or a data link network, or do I need to move a whole picture under an advanced waveform from one battle management asset to another? Maybe an airborne battle management asset to one on the sea. And I need to move that entire picture with latency so it presents the same picture to decision makers no matter where they are. So I'm nuclear power trained, so I've got a graph, but I'm a fighter pilot, so it's a very simple graph. If we match our programs between program value and time, say Chipper is sitting in the offices over there at Defense Headquarters, team comes in to present to him, they want to spend money on a project. It's going to cost $25 million. Okay, what do I get? You get this. This is our schedule. These are our assumptions. We look at a PowerPoint brief, very expertly delivered by people we trust, and we say, okay, I trust that. Here's all $25 million. Go ahead, Mike, let's present, and just to make sure we're on track, we'll do periodic reviews. So we put all of our money and resources, and this early man's got a laser, so watch out. Right there, in the most risk, with the most uncertainty, we put all of our resources right there. And then we get out here someplace and we say, hey, it's not really on track. maybe our capability is a little bit, and we go, yeah, stuff's risky. I mean, we just didn't see how this was going to work. Better take my thumb off this so I don't get Bill in the eye. Okay, and I need a little bit more money. And I need a little bit more time. That IOC was going to happen in 2022. Well, now it's in 2024. Instead, same presentation comes in. In that uncertain time, Chipper says, those 4 assumptions you have you tested those assumptions? No, but that's part of the program. We need money to do that. Well, okay. Back up a little bit. Slow down there, cowboy. The first assumption. How much does it cost to test that first assumption? Well, it's about $200,000. Okay, how long do you need to test that first assumption? 3 weeks. Okay, here's $200,000 in 3 weeks. Go test that first assumption. Come back and tell me that it works, and I'll give you the money for the second assumption. Thereby creating value as we go so that our resources go match the risk that we have going forward. We need to do that. We don't do that in the Pentagon. We don't do that in industry. We want to get all the money up front so we can show business in the future. I have a backlog. In the military, that is an anathema. In the commercial world, a backlog shows that you're going to be viable for a long time, and the street loves that. It doesn't do us in the defense industry or do us in this competitive world any good. We have to figure out how to change the processes to go forward and still have wins in the business world, wins in the defense world, wins in the competitive world partnering together. Here's my imperatives as I looked at this over the last several years. When we innovate, prototype, experiment, and demonstrate, we need to actually demonstrate, learn something. It goes to failure, or we learn and then go from there. I got in a little bit of a fight I lost with John Richardson, the Chief of Naval Operations, about failure. And he said, we're not willing to fail. I would stand up in front of a group and I'd say, Elon Musk was willing to fail. In September of last year, his rocket blew up at Wallops Island. In December, he launched another one. In defense, can we do that? Can we respond that fast? To be willing to fail. The Admiral's contention with me was we have to have tolerance for failure. Okay, like my tolerance for pain is about right here. Is your tolerance for failure at your shoe soles or is it up here at your shoulders? I'm going to risk big things, but I know the risk, I know the rate of return. The other piece is key for those war fighters that are out there. Steely-eyed operators who are waiting for the new thing to show up in order to be able to do better, operational risk. But in the acquisition world, in the engineering world, boy, we're going to make it perfect. It's not ready to go yet. We don't do early adoption in the military. We don't hand the new iPhone 10 to somebody and say, hey, how do you think this works? Come talk to me later, see how it works. Early adopters. And so the warfighter waits while we manage risk down to nothing. We need to match the acquisition engineering risk with that operational risk. System of systems approach, integration and interoperability. Kill web shortly. If you're coming to Williams tomorrow, we'll talk deeper about kill webs. Imagine kill chains, horizontal, now stitch them together so that any sensor, any shooter, any effector can complete that kill chain. You start to mesh it together, you got a kill web. It's a systems approach. You need an independent kill chain where I can take my F-18 with a gun and shoot somebody all the way to completely interdependent where that network is operating together and can't do its thing without being interdependent. Federated, integrated, in and out, aggregating, disaggregating. Information flow. Modeling, simulation, and analysis to be able to replicate the real world. You're going to hear two great speakers this afternoon talk about live virtual constructive. The mistake you will make thinking that live virtual constructive is a new way to do simulators means you don't understand the nature of the high-end warfight. Think Ender's Game. Immerse the operator in an environment such that it is every bit as real. All the models are physical models. They're connected together. We have to create waveforms to take data all the way from unclassified to sensitive compartment information off the airplanes that are airborne and put them into the site to be able to mold with the virtual simulation or emulation that are all being shown the same constructive environment. Everybody's operating on the same sheet of music. We're going to optimize the government industry team. In this fight going forward, two things. First, we have to connect what we have already fielded. You're going to need a cross-domain solution to do that. Your E-7 is already engineered a certain way by Boeing. Your Joint Strike Fighter is already engineered a certain way by Lockheed Martin. How do you get them to talk? You need a cross-domain solution to do that. And it isn't as simple as, here, just take this radio that I have in my airplane and put it over there. Everybody has the same. But it is about software-defined radios and software-defined networks. Your Air 6500 is an outstanding example of a chance to create the best athlete as you go forward. You have companies in Australia that do parts of Air 6500 to create an integrated air and missile defense capability later on. You must partner with the services. Who gets the prime system integrator? Can it be the government? Probably not. We're trying that in the United States and we're not doing so well. So we have to partner with industry. So who in industry is the best prime system integrator? And then who brings pieces of that together? And everybody has a piece of it. You can't just be king of the whole thing. How do you create the national capability in any of our countries to be able to put our key capabilities together? The engineering solutions to integrated fire control are hard, and you have to do them early now because you already have fielded systems. Your Royal Australian Air Force is recapitalized with the highest end systems in the free world today. You have a wonderful opportunity to put them together and have the greatest fifth generation informationized force in the world today. You don't have to wait for anybody. I've seen it myself. I've tried to create an integrated force in the United States Navy, and it's hard. And I'm telling you, you have a great opportunity right now. Go. Don't wait. Get your innovators to start putting it together. Put the best athletes out there and have these discussions at the national level, government and industry. Different name tags, different labels, L3, Lockheed Martin, Boeing, CAE, Northrop Grumman, RAAF. Tim Bartlett stood up here and talked about creating the Navy. Who's thinking about connecting the RAAF with the RAN, the E-7 to the air warfare destroyer and taking a whole picture out of the E-7 and sticking it on the Aegis weapon system on the air warfare destroyer? Oh, sorry, can't be done. Lockheed Martin. Boeing, I can't move that. That's not the waveform we have. You guys break it open. Best athlete. But all of this stuff requires a secret. So if we were sitting here, by the way, for you that are going to sleep, in my last slide, if we were sitting here today with a group and maybe all the junior officers that are in here, I'd just key that question at the bottom and I'd wait till somebody answered it. Because I'm running out of time, I'm going to lead you through this. 1942, carrier aviation moved from a battleship Navy to a carrier aviation Navy. Billy Mitchell demonstrated decades before that you could bomb and sink a ship. Started talking about aviation. He got court-martialed. Court-martialed for his beliefs. Our speaker last night at dinner talked about Douay, the French aviation theorist, being put in jail for his thoughts on aviation. Incarcerated. He pushed through. The admirals in World War II, United States Navy, John Towers, Halsey became a qualified aviator. They pushed aviation. Hyman Rickover with the Nautilus, nuclear power, risked then a development that we would not take now. He created that system, created the rule set around it, and pushed it against all comers himself. The Aegis weapon system, Wayne E. Meyer, force of personality. The F-117, Kelly Johnson, using a lot of F-bombs, pushed back on big Air Force and said, get out of my way, I know what I'm doing. John Boyd, F-16, the only reason the F-16 is alive today is because John Boyd completely slaughtered any opponent in front of him. So what's in common here? A human champion. Somebody who is ready to stand up and say, this is where we're going. Sometimes those champions are singles like Hyman Rickover, Wayne E. Meyer, Kelly Johnson, and sometimes it's a team. And I think in this fifth generation fight, represented by the Integrated Battle Force of 2030 down there, there might be more than one champion, but you need a champion set of people. And it's my hope, and I thought this in uniform, that we don't have to go to war to be able to figure this out. Ladies and gentlemen, it's been a real pleasure to be able to introduce some concepts to you today. Some of the rule sets were sort of, okay, it's a set of rules, while the concepts and the other speakers are more provocative. But I think you heard some common themes, and I continue to hear common themes from yesterday to today. So I encourage you to continue to stitch them together and take the opportunities that are in front of you. Thank you very much.